Hi, in this video, I'm going to demonstrate to you on how to carry out the Whitworth's quick return motion experiment to collect the required data from the experiment. This is the Whitworth quick return motion apparatus. It mainly consists of a crank with a fixed radius, a lever with a slotted link, which is linked to the crank, and you can see an extension piece here with two pivotal links with a fixed length, and there's another link here which is linked through a lever, longer lever, to the slider of the apparatus. You can also see two scales here. So this is a horizontal scale to read the displacement or position of the slider, and a circular scale for us to actually read what is the angle of the crank in degree. So this is another quick return motion apparatus. So this mechanism is applied in the shaping machine. So in the shaping machine, so we have the cutting tool which is fixed here at the slider, and this crank is rotated using the power from a motor. So this is another mechanism. Not only we can actually convert rotational motion to a translational motion so that we can have a cutting process in a shaping machine. But with this mechanism, when it converts a rotational motion to translational motion, so it also gives us a quick return during the returning stroke of the cutting process, and a slow motion during the cutting process of the machine. Not only that, as you can see here, so during the during the rotation of the crank or of the motor, so you can see this radius changes. So radius is getting bigger, right, at this position, and then at another position here, you can see the radius between this link and the point of rotation O is smaller. So we know that the torque required for a machine is force times radius. So when the radius is bigger, this will give us the highest torque. That is during the cutting stroke or cutting motion of the machine, we need to have a higher torque in order for the cutting tool to be able to cut the workpiece easily. Well, before we start with the experiment, so rotate the crank for a few complete revolution to make sure that the apparatus is working fine without any problem. Then the first step is set the crank using this label here to an angle of 0 degree. So at 0 degree of crank angle, so jot down what is the position or what is the displacement of the slider. And then for every increment of 10 degree of the crank angle, so jot down the position or displacement of the slider until a full complete revolution of the crank, and the crank return back to its initial position of 0 degree.